this. Okay.
Tweet it. All right. Hey, everybody. It's the ASP.NET Community Stand-Up, and this is a very special edition of the ASP.NET Community Stand-Up because Damian Edwards has gone to great lengths, there he is, to set up a camera, a number of cameras, in fact, and this is the room here. This is up at Redmond. Here you go. He's panning around, and we're looking at the very exciting, no one is there, apparently. John Galloway is randomly walking by.
Yes.
No one shows up at 9 o'clock, apparently.
Well, there's one person. I think Andrew's behind
Andrew.
John.
There's John. John's visiting.
There's Andrew.
But everyone else is
all the way around this way. Oh, that's as far as the camera goes. Yeah.
That's as far as the camera goes.
Pavel is sitting right here, and Murat's sitting down there, but you can't see them.
Okay. And is that where you sit? Is that your machine right there?
No. So the camera is on my desk, so you can't see my desk. This is where Lewis and Alan stand, and this is where Fowler stands. But these machines are the ones that we've reappropriated for the ASP.NET Smurf Lab, as it's affectionately known, and we have a mascot and everything as of this morning.
So this is the Smurf Lab?
This is the Smurf Lab that we've been tweeting about and talking about for the last few weeks.
Where did the computers come from?
These are just developer workstations. So quite literally, this machine down here, which is the one I'm going to show you in a minute, is David Fowler's machine he got as part of the Windows 8 refresh 2 years ago.
Mm-hmm.
This machine down here was Levi Broderick's old developer workstation. This one, I think, was one of Lewis's, oh no, it was another ex-employee's workstation, and the one over on the end was Lewis's desktop. Now, they don't use their desktops, they use their Macs exclusively, so that's why we were able to reappropriate these. These two are Windows machines, these two are Ubuntu 14 desktop machines. So, and then we have new hardware. So we have a new switch that we got last week. This is our 10 gigabit Netgear 10 gigabit copper Ethernet switch.
Mm-hmm.
And
that's an expensive switch.
About $800. Not as expensive as I thought, really, when I started.
Oh, that's an expensive switch to be putting a bowl of cereal on top of.
That's actually some kumquats or apricots or something. Little
it
might be plums actually, but
they're classy. That's totally appropriate.
Look, what? It's so judgy. So judgy.
I'm not being
can't
judgy.
Bring in fresh fruit.
I'm not being judgy. I'm just.
Would you prefer a box of donuts?
We're showing people how the actual stuff happens. I think maybe they expected like a refrigerator-sized computer in a big giant room with like lights and.
I mean, like perf numbers are all relative, right? We just wanted something that was reasonably powerful that we didn't have to wait for between runs, and something that's indicative of servers as they scale up. So this machine this is a hexacore machine that's hyper-threaded, but it's still, like I said, it's 2 years old. It's the entry-level sort of Xeon workstation. It's nothing extravagant by any means. I think this workstation probably cost $1,500 when it was bought.
Okay, so then the perf numbers that you would get on this would be representative of the kind of perf numbers that the listeners and viewers would be able to get on their own machine someday.
If they have this type of, I mean, if you're using a laptop, obviously,
yeah,
and it all depends on what you're bound by. Like we had to upgrade our network switch to 10 gigabit because we were hitting saturating gigabit NICs fairly soon when we started doing sort of experimental server type stuff to figure out what should we build the next gen server on. So, yeah. We're also doing some compete analysis. We're looking at other frameworks in like Node and Java-based things like Scala and Haywire by Kelly Summers, which is a libuv C-based server, and so we're trying Undertow, another Java one. So we're looking at those things and trying to relate those numbers to the Tech Empower benchmark results. In fact, I think I even have that up here. I was looking at these last night.
So I'm going to switch. I'm going to show them. We've actually set up multiple machines here. So here we go. So this is Damian's machine. So this is the machine behind him. I just want to make sure that's clear. So he's standing in front of a machine.
Yep.
And I'm going to switch, and now we're looking at that very machine there.
Yes. So this is. As I said, this was David Fowler's desktop, and is now our Windows Server 2012 machine, the hexacore machine. And so then this is a PuTTY window over here over to the Ubuntu machine, which I use to generate load because there's some very good load generation tools that just work better on Linux than they do on Windows. In this case, WRK or Work is the tool that we use, which is the same tool that the Tech Empower benchmarks use. So yeah, there's been some interesting stuff here. We have a repo that people can look at if they want to kind of see the stuff we've been working on, which is up here. So that's ASP.NET/benchmarks. Now this is just, it's pretty unstructured so far. It's really just a wild west of crazy ideas that we've had. this will become a bit more structured over the coming months as we sort of delve into this a bit further. There's some normal servers here, like existing servers, and there's some experimental servers. So these things here, these aren't real servers. These are basically, command line apps that we've written to test out various different approaches to building web servers to see what type of
Nice.
profile they have, right?
Are those what you call spikes?
These are spikes, yeah, to explore new ideas. And the ASP.NET 5 is just a Hello World ASP.NET 5 app that we can run on, Web Listener and Kestrel and IIS with Helios, those type of things. But we had a great pull request to this by Ben Adams, sorry, who's one of the community members, that uses a new set of APIs in Windows called Rio, or registered I/O. So if I go to look at Windows, and I look at registered I/O, this was added in Windows 8, and it's a layer on top of WinSock that uses a new.
Control plus a little bit. It's very, very high.
Sorry. Yep. So that uses basically they're extensions to WinSock that let you do pre-registration of buffers when doing I/O, network I/O in Windows. And it turns out, that by doing that and sort of stating your intentions up front in the API, you can get crazy throughput. In some cases, more than double what you would get out of raw WinSock. So as I said, this appeared in Windows 8. There's a very good build video from 2011 about this if people are interested in it. And so we've known about this for a couple of months now. We've been wanting to, at some point, look at building an experimental server to see what it might look like. So anyway, Ben did that. And we started running some benchmarks on that yesterday. So I can show you how we do that. So I've got the CPU task manager up here.
So this is benchmarks on Ben's experimental server.
Yes, this is benchmarks on Ben's experimental server. Again, this is an exploration to see what this new API set in Windows might be able to do for us. Now, this server is not a real HTTP server. It literally looks at incoming bytes and only parses as far as looking for 2 carriage return line feeds in a row.
Right. Okay, so but it is managed code though, so it does deal with.
It's managed code. Yeah, I mean, I can show you the code, right? It's here, and it's a whole bunch of native interop stuff like this. Some structs and with stuff, and then he's got Rio receive task. This is a custom async await structure.
You're gonna scroll there for me.
Yep.
You can't see anything. There we go.
Right, and so this is
so it's managed. It's mapping managed structure to unmanaged structure.
Yeah, exactly. It's classic interop, and then the actual program itself is here. Like, this is the program main, and you can see that he's writing out responses. It's a fake web server, but it's really about testing the APIs and calling them.
Right. But it definitely will prove the point or answer the question if managed code can be really performant and clearly.
Yeah, and that was one of the things that we were trying to validate, right? Is there just some inherent tax in using C# or?
Can you right-click on the CPU there?
Yep.
And then make that logical processors?
No, because I want to show you overall.
This is what Nick Craver from Stack Overflow is asking.
Okay, so I can do that.
To see how many there are.
Well, okay, the numbers are here, so if you want to see that, you can see them.
Okay.
The numbers are down here.
Okay, cool.
But yes, we've been showing both because once you've got your code balancing across all CPUs, what you really want to see is overall. So.
Of course.
But fair enough. So I'm going to run the server. So the server's running over here in this PowerShell window. Okay, and I can go back to my browser and just test that it's responding, which it is. So I'm going to go back over to my putty machine now, and I'm running the work command, and I'm going to create 450 connections. The client is going to use 32 threads, and then I'm running a script which enables HTTP pipelining.
Can you pump that font up a little bit?
I'm zooming. Is that not working?
No, zooming doesn't work with Google.
I'm sorry. I don't even know how to do that in putty. Can you even do that live in putty?
No, not really. Not in an easy way. Yeah, change settings. Okay.
Change settings.
Appearance. Font change. There we go. Thanks.
There you go. Better?
Thank you so much. Because it's going to get downplayed with like 720p.
Yeah, I get it. So 32 threads in the client running a script to enable pipelining, which we've talked about before. So it'll send multiple HTTP requests before it receives any responses, and I'm doing that to a depth of 150 requests. So there's some pretty serious pipelining, but we've got serious hardware, so we want to try and stretch it here, and then off to that server. So I'm going to hit enter, and we can see instantly that I'm pushing 8.5 gigabits per second now through this server.
It didn't even ramp up; it just went boom.
It just went boom. Yeah, I mean, so
and
as I said,
going through the switch. Like that was not. This is not localhost.
No, not at all. I mean, this is
I
PuTTY,
just,
right? So it's going to
I know. I
Linux.
just make. I know this. I'm making sure that people who are watching understand what's going on.
Absolutely. So yes, this is running on a separate machine. This terminal here, the PuTTY machine, is
Hmm.
the far left one. And I'm putting into Ubuntu and running that work command. I can run it again. I'll make it run a bit longer. So let me do a duration of like 30 seconds. I'll run that again. And so we can see the CPU. And so yeah, we're doing 8.4 gigabits a second. The previous test finished at 7.7 million requests a second. Um, and you can see the CPU profile in terms of kernel versus user is good. Like most of the time it's being sent in kernel mode, which is good. It means that the kernel's working hard doing networking. The network driver is accessing memory and using
Hmm.
DMA and all those type of good things, and just a little bit of user overhead. And what we find is as we add more pipelining,
Hmm.
that CPU actually goes down because reading off the network becomes more efficient when there's more data to read, and Rio can really stretch its legs and do great stuff. So yeah, like this is looking really promising. This is we got these figures for the first time yesterday, and these are well on a well beyond any of the type of things that we'd seen before. For this type of like I said again, reiterating, not a real HTTP server, but
Hmm.
what's encouraging is that we're getting these numbers and we still have half the CPU left. So if we were to use the rest of that CPU to do things like, I don't know, parse the HTTP headers and actually put them into something useful, which is the next step here, then we're hoping that we can actually continue to maintain numbers in this realm because we have all this CPU to spare.
So then, speaking naively, of course, because we're all just speculating here, but given that what's going on in an HTTP request in ASP.NET 5 is a lot lighter weight and there's a lot less stuff that you need to go digging for,
Mm.
theoretically, you could do just what you said and make and plug in ASP.NET 5 on top of this.
Yeah, I
The
mean that's
question
the
would be like,
yeah
how much
yeah
do you
like,
need, right?
that's the idea. So there are many layers. I mean, even if ASP.NET 5 is obviously a lot less, you could probably switch back to the camera now.
So, hey,
ASP,
real quick before you do that, Nick
yeah,
Craver, again, Stack Overflow,
yeah,
says, are you pegging half the processors or half
no,
pegging all of them? That's why we
it's
look logical at all times.
it's equal distribution. So if I run that again, um,
So half pegging all of them. No,
well, kind of. You can
let me
see
ask.
that a couple of them, because
You're
of the way the
pegging,
kernel
you're
works. Yeah,
pegging six of them.
yeah. So, and that's because these are hyper-threaded, right? So, and because of the way that the network card is designed to work, it ignores hyper-threaded machines when it dispatches I/O work onto
Right.
multiple
Because
cores.
there's six physical processors and six
Correct.
hyper-threaded
So there's
ones.
a technology called RSS, or request side streaming, which
Uh-huh.
these NICs support, which will actually farm out the work to multiple CPUs as bytes come in off the card, and then
Hmm.
pin that connection and resultant I/O on that connection to a particular CPU, so that you
Hmm.
get the efficiencies of things like having the memory in level 2 cache not be overwritten when the socket jumps from one CPU to another. So that's all. That's some of the features of advanced network cards which we have in these machines now. So that's why we're seeing this type of profile. Some of the other servers we ran before we had these cards, you would just see it trying to saturate all CPUs, and it didn't know that they were hyper-threaded or not. It just didn't care. So
Yeah. It's
anyway,
amazing.
sorry, what were you saying?
I'm saying that's amazing. It's really cool.
Yeah, it is cool. So what was I saying? Yeah, so in terms of like getting this to be something more real now, one thing that's you have to be very mindful of is like when you're doing tests at this level, the smallest delay in any code to do with request processing can have a dramatic effect on the RPS that you end up getting. So we have to be, even though we've got a 50% CPU spare at the moment, if we end up taking 45 milliseconds to parse headers, that could result in like half the performance because of the way, depending on where you do that work, especially with systems based on something like libuv, where you have a dedicated loop that runs on one thread to do all I/O work. If you stall that loop in any way, that loop can no longer read bytes off the network card. It can no longer send bytes on the network card. So it's extremely sensitive to being delayed. And so even though you can get good numbers here, as soon as you start doing real things like processing request headers and parsing the request body and things like that, you need to be really, really careful. So we're doing crazy profiling now. We're looking at how other frameworks do their HTTP parsing to get some understanding of how they manage to keep that overhead really, really low. And it's all the type of stuff you think about. Basically, everything is really lazy. You never parse anything from bytes into the actual thing that you want it to be until someone asks for it. All that type of stuff. So yeah,
It's hot.
it is hard.
Yeah,
Yeah.
I'm saying that because I was being teased for saying that's hot too many times in the Visual Studio keynote yesterday. It's one of those things where you say something once and then it gets stuck in your brain,
Yeah.
and unfortunately that got stuck in my brain.
Yeah.
But that's pretty sweet. Is this something that we should keep sharing, like from week to week? How hard was this for you to set up? Maybe we can do this maybe every other week or something like that on the
Oh,
stand-up.
now that it's set up, it's easier for us to do. And we have like a list of things that we're working through now. So we've got a couple of experiments. We're going to try one of the other servers we have is TCP Echo, which is basically what you just saw, but built on top of libuv instead of built on top of Rio. And so that gets about 2.4 million requests a second, but it saturates the CPU. So the profile is completely different. So we're going to add the HTTP parsing onto that server using the new code that we've had, like as of yesterday, the highly optimized HTTP parsing code that we've written in the last week, and we're
Mm-hmm.
going to look at what that effect has. And then obviously all this finally will bake down into Kestrel, which is the new web server we're writing that will be cross-platform. And we're now trying to figure out whether, previously we were just going to build Kestrel on top of libuv, and it would work on Windows and on Linux and on Mac because of the fact it was libuv. But after seeing these numbers on Rio, we're reassessing. We're saying maybe we should make Kestrel support libuv and Rio if it can, or maybe we should get libuv to support Rio if it's on Windows 8, if it's a
Right.
good fit. So we're looking at
Well,
all those type of things as well.
and this is the kind of like let's just say competition, right? Like friendly competition. Like Rio, if it's better than libuv on Windows, then Kestrel would light up on Windows, and then if there's some new thing, some new acronym that comes out on Linux, then we would make it support that, and you'd kind of tick-tock back and forth.
Yeah, and as I said, if you flip back to the Tech Empower benchmarks here, ultimately what's driving a lot of this, if I flip to plain text, which is the benchmark that actually tests just the HTTP part of the server and quite literally nothing else,
Uh-huh.
then what we're really interested in here is, look how many of these are Java.
Yeah.
Like the top two are C++. Well, okay,
So
good, but look at
context,
these four.
so plain text, this is Echo, right? This is doing what you're doing.
No, this is doing more than we're doing. So, but to be clear, like we're cheating. The tests that we were just showing you, they're not
Okay.
HTTP servers. They're a TCP echo server that can look for carriage return, which is the end of an HTTP header payload, right?
I see.
And so these ones are actually doing proper, like Undertow. If you look at the code for Undertow, like what an app looks like, it looks like ASP.NET 5. Like you have a handler, you have a pipeline,
Oh, okay.
you put delegates. It's a real HTTP application server. So these numbers are sobering. We've talked about this before, right? And so
Right,
this
right.
is what's driving this effort. It's like, well, they do it on Java. There's no reason you
So
can't
you
write
could
code like.
go. So just to be clear, Undertow in this benchmark isn't cheating. One could put that into production. It is a real thing.
Yeah, it's a real thing, and just
Yeah, yeah.
as Netty and
Right,
those type
right.
of things, obviously a very plain servlet on Linux. There's a plain Windows benchmark here. If I flip back to round 9, plain Windows, that's Scala. Like
Mm.
Twitter uses Scala. Like Scala is a real thing, and that's
Right,
running
right.
on
The
Windows.
reason I'm
That one.
pointing this out is I want sure to make sure that your point gets
Mm,
hit hard, which is that our cheating web server, which does the least possible amount of stuff to respond to a request,
mm.
is looking great. Then the question is, as you put HTTP parsing on top of it and you put useful work on top of it,
Yep.
where might we potentially fall
Yeah.
in the
So
benchmarks?
we're all the way down at this point. We're starting again from scratch. So we've gone all the way down to what API we're using at the OS level to talk to the socket. And that's what we're kind of looking at right now, but doing it from .NET. So that we have like the managed stack on top of the native stack, but we're assessing how good these APIs are and how we do memory management, those type of things. And next step is to go, okay, well, let's actually turn it back into a proper HTTP server. And
Mhm.
if you want to learn more about the requirements for this test, you can go up to source code and requirements. And if you scroll down to the plain text, it actually tells you what you must do to be a valid plain text benchmark. So all the way down here. So
Yeah.
you must actually do request parsing, like you must do routing. We're not doing that obviously yet.
Right.
You must set a minimum of these headers. You must create a date, and you must set that in a header, right? It says that it's not intended to
Ah,
exercise the allocation of memory, so you can just resend hello world from the same buffer. What you can't do is send the entire payload from a fixed buffer, which is what we're doing right
this
now.
is the explicitly how not to cheat
This is the
rule.
explicitly how not to cheat rule, right? And then
Yeah.
it tells you it'll be exercised with certain levels of concurrency, and they'll average
Right.
the results and all that type of stuff. So
That's very cool. This is exciting stuff. It's fun that we're doing it out in the open too.
Yeah, I think so. I mean, it doesn't really serve anyone to do it all in behind
Mhm.
closed doors, I think so.
So people can set the, like it's like you said, it's just brainstorming in spikes, but people can set this up now, and if they have thoughts, they can get involved in the issues and GitHub.
Yeah, I mean, again, as Ben has done for us already, he has very graciously built this Rio server for us that we're testing like heck right now. So
Oh, big
it's
thanks
good.
to Ben.
Yeah, absolutely.
Oh, very cool. This is great. So if people like this, we'll do more of these. Damien has been very thoughtful and worked with John Galloway to set up what looks very simple, because hopefully it went smoothly, but it involved multiple computers, multiple screen shares and cameras and zooming and headsets and stuff.
Yep.
So this is pretty slick.
Do we
Pretty
want to
quick.
answer the four questions we have before we, or
Yeah,
four or
let's
five?
bang those out real
Yep.
quick.
Okay. I can't read them from
So,
here, so.
okay, so the question is, are there any gotchas for VSRTM and being on nightly builds other than what Andrew Nurse announced?
Uh, if you want to switch me back to the camera.
I did.
So I'm assuming Andrew Nurse announced the problem with the. Yeah, so we have one known issue, which was a botched rename. You can work around that right now by setting an environment variable. That's the only gotcha that we're aware of if you're using VSRTM with the dev branches on GitHub.
Okay. What is the botched rename?
We go through multi-phase renames now whenever we rename one of the runtime components so that VS tooling continues to work. But people are turning up now.
And
But
walking
we
right in front of our camera.
yeah, but we got one wrong, and so
I
VS is looking for something of one name, but it doesn't exist yet, and so we're fixing that in next week's release.
Oh, okay, cool. So that's a small thing.
Yeah, it's a small thing.
Okay, cool. With the ASP.NET 5 roadmap now published, are there any features in 4.x that will not be in ASP.NET 5 RTM?
Yeah, so HTTP2, certain elements of it. So if you're running ASP.NET 5 on top of IIS on Windows 10, or you're running it on Web Listener on Windows 10, you will get header compression and connection multiplexing on HTTP2, but you won't get the push promise API. We haven't written the API in the ASP.NET 5 layer to let you push responses back as part of the HTTP2 spec, and that probably won't make it for the RTM of ASP.NET 5. It'll come after that. That's probably the only thing I can think of that you would class as something that ASP.NET 4.6 has that ASP.NET 5 won't have.
And then Luke wants to know with RTM, do you uninstall RC, then install RTM, or you do an in-place upgrade?
No, you can do an in-place upgrade.
It worked fine.
Yeah, in-place upgrade is absolutely intended to work.
Yeah, so that worked great. So, and the final one is, is there any guidance for SignalR as it relates to ASP.NET 5 once it RCs and RTMs?
Yeah, so the roadmap states that SignalR has been unfortunately dropped from the scope for ASP.NET 5 RTM, along with web pages before it and Visual Basic, which will come shortly after that. So right now, I think we won't be releasing any more betas of SignalR 3 until after we've shipped ASP.NET 5 RTM. So beta 5, I think, was the last one that we shipped. Some of it works. I think WebSockets works, and I think long polling works. I'm not sure Service and Event works. We haven't done a new JavaScript client yet, but the existing JavaScript client 2.x works just fine. So if you want to use SignalR in an ASP.NET 5 app, you'll have to continue using beta 5, but it may stop working at some point. Like we've just had to
Right.
postpone it, unfortunately.
And this is not a vote of no confidence or any concern. It doesn't mean anything about the health of SignalR or appreciation for it. It's just, hey, schedules.
It's just prioritization and schedules. It's exactly what
And
it is.
web pages.
Web pages is the same thing. So right now we've got them slated to come in the initial release after we RTM. So I've put them down as Q3 next year. So that means July through September next year.
Okay. Stuff that we want, just stuff that we can't get out of the box. You can't get it all.
We can't get it all. I mean, the list is much bigger than that, obviously, but the list starts delving down into smaller items. Those are the big three.
Yeah.
I think that people would consider massive takebacks that we've had to say up front. We don't have time. They're big items, and we need to get a good solid foundation out, and then we can do it. I mean, and I hope people appreciate that. In the mantra of kind of release early and release often, we're trying to do that, and in order to do that, we have to cut some stuff and then do it after we get the initial release out. So.
This is just my question, kind of a final question. Do you see it being possible that we get a mature enough community that someone could potentially take one of those features and work on it in a team? Like we've seen the .NET Core folks have a team on their own port to FreeBSD.
Yeah.
Could someone work on SignalR or go and work on web pages on their own?
They certainly could. I mean, I hope they do it on their own. I hope they do it with the
Not like with
community and they
when I say
work with
on your own, I
us.
don't mean like disappear for 6 months and roll in later, but like talk to you and say, we, the people of I don't know the Isle of Man user group, have decided to go and work on web pages for ASP.NET 5 because we think it's really cool.
Yeah, so I mean, the thing with web pages is that when we
Just as an
do,
example,
yeah, when we do web pages, okay, I mean, web pages is an example, and I could drill into why
maybe
web
it's a
pages is
bad
probably a
example.
bad example. Signal is probably a better example because, fundamentally it won't change in
Mm,
version 3. Web
okay.
pages will probably change quite a lot because the web pages we had previously really didn't relate to the rest of ASP.NET very well. It was quite a standalone thing.
I see.
Right? So we'll redesign web pages for this round. But for Signaler, you could certainly, a group of people who were determined could obviously go and try and keep it up to date and look through some of the backlog items that we've logged there and attempt, and work with us to try and figure out what should be done first. But it's a little different to something like the FreeBSD effort, where that is a community effort that will be supported by the community, whereas obviously Signaler 3 will be supported by us once the work is done. So that's the only thing I think that would differ between those two things.
Very cool. This is exciting. Thanks for taking the time to set all of this up. I know it was non-trivial.
Yeah, not a problem. The worst part was that Hangouts didn't work for the first half hour today.
Yeah, Google Hangouts was down when we were going to start this early, and it was down.
Like, we were on time. I want to tell people,
We
like,
were
we were ready
totally
to
on time.
go.
Yeah, we woke up early.
Yeah, never
So
mind.
can you do a dramatic zoom out from this angle?
I can try and see if this remote will fit. Otherwise, I'll just walk far from the
Oh,
camera.
it works.
That wasn't
That
so.
was not very dramatic, though.
It was kind of just harsh, but never mind.
Yeah. Oh, and then people are asking about your Iron Man GitHub shirt.
Oh, it is an Iron Man GitHub shirt.
Oh, okay. Where did
You
you
can
get
get
it?
them from. I got that from the GitHub headquarters in San
Oh, okay. So
Francisco.
this is on GitHub headquarters. Cool. And then who's this random guy?
This is Alan walking into our live, community stand-up.
He's run away. All right.
Subtle.
Bye, everybody.